Okay, I'm going to go ahead and get started, despite the fact that I'm the only one in the room. Last time we were talking about strokes. In medicine, of course, they call them cerebrovascular accidents. Stroke can be an aneurysm, a stroke can be caused by a blood clot, or it can be caused by a break in the blood vessel, a hemorrhage in the brain. Of course, if you bleed into your brain, that's a fairly serious situation. The vast majority of strokes are caused by blood clots, and for that reason, we have a medication that we can give somebody who has had a stroke, and it will break up that blood clot. Now the problem is that if, well, let me aim this thing a little bit better. There we go. The problem is that if we give this person, the person with the stroke, the clot breaking up mechanism, or the chemical, what will happen if they have a hemorrhage is that they will bleed more excessively and it will kill them. So we have to be very careful if we are giving people, if we're giving them this medication, we have to make sure that they actually have a blood clot. And this of course takes a little bit of time to figure out if somebody's got a blood clot or if they have a hemorrhage going on in their brain. The vast majority of strokes, of course, are caused by blood clots. The stuff's called TPA. It's actually 3 different chemicals that we put together, and it will dissolve a blood clot. Hi, Scott. It will dissolve a blood clot, and that's a good thing. Once upon a time I had a heart attack. No, I'm good. Once upon a time I had a heart attack. And when I was at the hospital, they kept trying to give me morphine. I kept telling them that morphine didn't work on me. So the doctor thought that I was having a stroke. He assumed I was having a stroke even though I didn't have any paralysis anywhere. He assumed I had a stroke because he thought that was completely illogical, and you know, I was being irrational, and so he gave me the TPA. Well, I agreed for him to give me the TPA. I didn't have a blood clot in my brain. Certainly, I wasn't having a stroke, and everything turned out okay. They put stents in my heart, and everything was better. Turned out that I didn't even have a blood clot in my heart. What happened was I exercise a lot, and I lift a lot of weights, or at least I did back then. Anyway, I had expanded the blood vessels in my heart to the extent that they were larger than they should have been, and I was under stress, and one of those blood vessels crooked over, and it blocked my blood flow. So I only had about 11% blood flow into my heart.
What's a stent?
A stent? Mm-hmm. A stent is a plastic tube that they stick in there where the blockage is, and it opens it up.
Is it like kind of like the tube that they put at the end of an IV, little plastic?
Well, it's actually a webbing.
Oh.
It's kind of a plastic webbing, or Teflon actually, and it just keeps the blood vessel open. And it saves your life. So we're talking about strokes. Stroke in the right parietal or temporal lobe causes undue cheerfulness or joking, denial of illness and apathy. So if it's in the right parietal or the temporal lobe over here, if it's over in this section of your brain, then you're happier than you were before, which is kind of nice. If you have it in the left temporal lobe, especially in the basal ganglia area, it can cause depressed mood, daily mood variation, loss of energy, anxiety, restlessness, worry, weight loss, decreased appetite, early morning awakening, delayed sleep onset, social withdrawal, irritability. All these negative things can happen if it's on the left side of your brain. If it's on the right side of your brain right here, you're in better shape. If it's over here, now you're grouchy.
But back,
If it's in the back, well, that has to do with your eyesight. Oh.
that explains a lot.
Bilateral hemispheric lesions or any lesions in the brain can cause frequent brief laughing and or crying, crying that is not caused by sadness, social withdrawal secondary to emotional outburst, and of course they have as I said last time, Samuel L. Jackson is, I think it's Samuel L. Jackson. Anyway, he has it there. Has advertisements about this, and if somebody cries frequently for no reason whatsoever, you're supposed to understand that they have this problem. Cerebrovascular accidents in the right basotemporal or right orbitofrontal region can cause elevated moods. That's right back here. So, is that on? Yeah, it's on the right side. Yeah, so that's right back here. Elevated moods, increased energy, increased appetite, decreased sleep, feeling of well-being, pressured speech, flight of ideas, grandiose thoughts. I know this sounds like schizophrenia or bipolar disorder, a manic phase of bipolar disorder. And then they look very similar. It's a blow to that portion of your head, or it's a stroke in that portion.
What does grandiose mean?
Grandiose, I can take over the world.
Oh.
Yeah, okay, that kind of stuff. I'm the smartest person, the best looking person there ever was. Maybe that's what Trump's problem is. Somebody hit him in the back of the head.
Real hard.
Yeah, real hard, exactly. Studies looking at the fear response in animals and humans have discovered that the amygdala, part of what used to be called the reptilian brain, is the structure that mediates fear. This is where the amygdala is. As you can see, these red spots are the amygdala. They are on the end of the basal ganglia. Amygdala means almond because it's almond shaped. This is where our fear comes from. It gets kind of interesting after this. Pictures of fear-inducing images shown to individuals will elicit blood flow to the amygdala. So if somebody is afraid, or if they see somebody else that's afraid, what will happen is there will be increased blood flow to the amygdala to warn you that you need to do something. When a woman without an amygdala was shown a picture of a woman smiling, she recognized the happiness. When the same woman was shown a picture of a woman that was afraid, who was registering fear, she didn't recognize the emotion because her amygdala was gone. And that's where we recognize fear. So if somebody doesn't have an amygdala, they know no fear. They don't recognize it anyway. They don't recognize it in other people, and they don't feel it themselves. So the amygdala has something to do with fear. It also has something to do with aggression. And we're going to talk about aggression right now. Researchers looking at aggression have discovered that cross-species elevated androgens means elevated aggressive tendencies. So the more testosterone you've got, and this is one of the things that we have noticed. If we drew blood from a ranger unit or from a marine unit, one of the things we would find is that they would have high testosterone levels. All the people in the unit would have high testosterone levels. This is one of the reasons I was reading the book by Kyle. The sniper. Chris Kyle. Yeah. And he was talking about his SEAL team would just start fighting each other. They'd grab each other and they'd try to capture. You had to be on alert all the time from your friends. These are the people in your own unit, and they would just grab each other and they would try to knock each other out by holding them and putting using a pressure point and knocking people out, which sounds stupid to me, but then again, I was a medic, I wasn't a SEAL, so maybe this is something that they would do. But of course, that has to do with a high testosterone level. this level of aggression. A normal person in a normal situation wouldn't think of doing anything like that. But here is a whole group of males, and they're trying to knock each other out. And they're friends, or at least they claim they're friends. They call them each other friends. Well, I wouldn't knock a friend out. I wouldn't grab a friend.
Training.
That's what he said. That seemed a little strange to me.
So it comes a whole different realm.
It has to do with aggression. It has to do with testosterone. Supporting evidence, when a male subject species is castrated, androgens and aggression both will drop. In other words, their testosterone level will go down because we've cut away their testicles, and the testicles, of course, produce the testosterone. And their aggression will go down.
So the way after dogs, as soon as they get fixed, they're like real calm.
Yeah, and that's one of the reasons why we do that. Why people will castrate their dogs. They don't want them to fight. Injecting testosterone into a castrated individual leads to increased aggression. But it's not just with males, it's also with females. Both males and females produce testosterone. Both males and females produce the female estrogens. So whether you're a boy or whether you're a girl really doesn't make any difference. You've got the same hormones splashing around your system. The difference is that as a male you have different levels of testosterone, different levels of estrogen than a woman does. In a study looking at female prisoners, it was found that women in prison for unprovoked violence had higher testosterone levels than women in prison for defensive aggression. Similar results were found with veterans showing antisocial behavior. And this is one of the things that we've noticed. And this is one of the reasons why it's so difficult for veterans once they come out of a combat zone. We used to see this with individuals coming back from Korea or coming back from Europe, where they were on relatively high alert when they were overseas, and when they came back, of course, I was in the military after Vietnam, in between Vietnam and the problem with the Middle East. There wasn't a whole lot going on. But we still had lots and lots of troops all over the place. And the reason we did that is because we were trying to face off against the Russians. We're trying to make sure that the Russians didn't do anything stupid. And of course, every time they did something stupid, we needed to send troops to that area. So there was a lot of that going on in the 80s, 70s and 80s.
Yeah, in Afghanistan, there's still minefields from the Russians.
From the Russians, exactly, yeah. And I was in Germany. I was in Germany when the Russians invaded Afghanistan. And the fear was that they were using that as a decoy and they were going to invade Europe. They were going to invade Germany. And they actually had tanks on the Czech and East German border.
Yeah.
Yes, they did, and it was kind of an interesting situation. It was an interesting time. So when you were overseas, when you were someplace like Germany, where you were minutes away from a Russian attack, your level of testosterone would be a lot higher than it was after you came back. I went from Ramstein to Offutt Air Force Base. At Ramstein, of course, you were on alert all the time. At Offutt, you were never on alert. So, I mean, the difference, and you worked 8 hours a day. In Ramstein, it was a 24/7 situation. So we were on alert almost all the time. So you went from being on alert for all the time to not being on alert at all, almost like being a civilian. And it felt like being a civilian. So it took time to adjust to not being on that constant alert. And I'm sure you understand what I'm talking about. It's the same thing happens with, and that's one of the reasons why people coming out of a deployment situation, a lot of times when they come back to the States, they get in trouble almost right away. And a lot of times it has to do with aggression. They become belligerent.
Yeah, I've been corporal twice.
Yeah, exactly. And that's what's going on here. So the individuals, and there are women with higher testosterone levels. And you can see this when you look at military personnel. The females in the military have higher testosterone levels than the civilian females. Why would they have higher testosterone levels? Well, one of the reasons they joined the military is because they had aggression, or they were aggressive. They had ideas about things, about defending the country, and therefore they had a higher testosterone level. It's kind of a curious situation.
I wonder if it was like that before they started letting females in combat arms.
Well, they had no, it was really kind of interesting. When I was in high school, back in the 60s, there were no female athletics. They didn't run track, they didn't play volleyball, they didn't play softball. This was a brand new thing. Then in the 70s, they started letting women play sports. But of course, in the military, almost all the females were either they were clerks or they were in the medical field. That's the only place you found females. And then all of a sudden, of course, they started letting them in other jobs. They were saying they couldn't do the jobs because they weren't large enough, they weren't strong enough to do it. But then, of course, you had more and more females joining the military, joining the Navy. For a long time, they wouldn't let women on ships, so they had to be in port.
Yeah, they just barely let women join Ranger School and infantry. Like, it hasn't even been 5 years yet.
Yeah, exactly. It hasn't been long at all. Combat arms were not something that women were allowed to do for a couple different reasons. One reason is because they didn't think they had the stamina to be able to handle the combat, and the other reason was because they didn't want to lose the females. Females are worth a lot more than males are. Males are a dime a dozen, and each female is worth a child. And for that reason, there were a lot of countries where women weren't allowed to fight, and including the United States. We were one of the last countries. Of course, Israel has had females under arms for from the beginning, yeah.
Right.
And they actually teach them different martial art techniques.
Magna,
Yeah, something like that.
yeah.
Gail Gardeau, the Wonder Woman, she's
Yeah,
she's
she's
idea.
a little bit,
Yeah, she has that capability.
Well, you have to.
I'm
This
sorry?
country law,
Yeah,
was it like 5 years or 8 years or something like that? Once you turn like 18 or 16 or something?
and everybody has to fight because if they were ever overrun by the Arabs, it would be a massacre. So they have everybody fighting, except for the little kids. You don't want to mess with the Israelis.
I worked with them too. IDF.
IDF, yeah.
Yeah.
Yeah, they're tough.
They got good bread.
Oh, is that right?
Yeah, it's pretty good.
Oh, I never thought about that.
I couldn't read because it's in Hebrew, the
Yeah.
writing.
Sure.
So I guess I was just talking to this guy, like, hey, what's up, man? And he was like, fucking commander, like, I don't know your rank system, man.
Yeah.
He goes, it's okay, my friend. So, all right.
Okay, so we know that women have the same problems that men do as far as aggression is concerned. Studies of monkeys and lowered levels of serotonin show that there is a negative correlation between serotonin and aggressive behavior. And this is what we now know. We know that testosterone causes people to be aggressive. That testosterone is in your hypothalamus. Your hypothalamus controls your sexual behavior, and it has something to do with your aggressive behavior as well. So we can control your If we have an individual that is oversexed, can't control their own sexuality, then potentially we can give them serotonin and we can control their sex drive. We can do the same thing with aggressive behavior. We can control their aggressive behavior through serotonin. The more serotonin they have, the less aggressive that they are. The less serotonin they have, the more aggressive they are. So we can give you, if we can give you serotonin, we can control your
Is that the same as SSRI?
SSRIs, exactly. SSRIs, and this is one of the reasons that people don't like to take SSRIs, is because it lowers their libido. It lowers their sex drive, but it also lowers their aggressive behavior.
Yeah, I was on a little bit, I was in the inpatient in San Diego. Yeah, they put me on that for a little
And
bit.
they put you on SSRIs and it controlled that behavior.
Yeah.
Yeah, but it took a while. It takes a couple of weeks for it to kick
Yeah,
in.
it took about a month.
Yeah. 2 weeks to 6 weeks to kick in. It all depends on how much you got in your system already.
I don't know how, I don't know, they didn't have a bunch of stuff.
Serotonin is not the only neurotransmitter that controls aggression. Hormones that control testosterone levels and the GABA system also play a role. And we see this as well. We can give you, one of the things that if you have too much anxiety, which is one of the symptoms of PTSD, we can give you a medication that increases your GABA level and your anxiety will go down. And if your anxiety goes down, your aggressive behavior goes down. So we can control all of these things with medications, potentially. Does take a little time for it to get into your system, however.
What's Seroquel used for?
Serotonin?
Seroquel.
Seroquel. I'm not exactly sure.
They have me on that, they have me on Klonopin.
Klonopin?
Yeah.
Klonopin.
What's that for?
Anxiety. Anxiety, but it's a really strong anti-anxiety medication. When it first came out, we were using it to control psychotic behavior. But then we realized it wasn't strong enough to do that. And we started giving it to people with high levels of anxiety. People that are suffering from, what am I thinking? Not phobia, well, a form of phobia. We would give them Klonopin. If you have a low anxiety level, but you still have anxiety that makes you non-functional, we'll give you Xanax. But for a high anxiety level, we'll give you Klonopin.
I've never taken
Seroquel.
I've been on
Seroquel is an anti-anxiety medication too, I think.
Zoloft, Paxil.
Paxil's an SSRI.
Prozac.
Prozac's an SSRI.
Freaking Seroquel.
It sounds like they were trying to control your PTSD.
Like a lot of people were like, how they're, like even doctors, they like, cause you get your, you get your ORB or ERB,
Right.
whatever, and then you get your medical record.
Right.
They're like, how do you walk in? I
Exactly.
was like, well, half of them I don't even take, man, because then it counteracts the other stuff, and then I'm just fucked.
Yeah.
But
Yeah, doctors aren't very bright.
yeah, Seroquel, it's
Anti-anxiety?
to
Anxiety?
treat certain mental mood conditions. It's the drug class is antipsychotic or atypical antipsychotic.
It's an atypical antipsychotic. Okay, we're going to talk about antipsychotics.
It's actually called quetiapine, Quetiapine.
I don't know.
Nah, that means dope, man. There was a guy here, he was an electric guy. And I know when he was on his medication because he was like just like a zombie. I saw him in Chin Lee. And he was walking normal. I'm like, dude, what's up? He goes, man, they just took me off it, man. I'm just going to counseling now. It's helping. And he goes, oh, I don't feel right when I was on it. You know?
Yeah,
It was
makes you
just
feel
like
dull.
floating and just didn't know what the hell was going on.
Well, that's the way she works, I guess. This is what I did in the service. Worked on people's immunity systems. The reality is that our body tries to protect us from alien structures out from the outside. You know, you're walking in the woods, and there's pinon pines out there. Well, they're putting off all kinds of interesting phytokenes all the time. So there are things there are alien structures that are getting into your body almost constantly. Viruses, bacteria, funguses, you've got all kinds of allergens out there, you've got all these plants that are putting off different structures. And we have to protect ourselves from all of these things. It's one of the reasons why you always get sick when you go to a new environment, like Iraq or Afghanistan. That's totally alien to us. When I first came here, I'd never been in a pinon forest before. This is a pinon forest. And of course, my body was trying to figure out what the hell was going on. Not only that, but I've never been at 7,500 feet before. And here, you know, now I'm living at 7,500 feet.
That was pretty flat, huh?
I'm sorry?
Where you're from is flat.
Well, yeah, it's only 400 feet above sea level. It's very flat. I mean, it's farmland. Of course it's flat. Yeah. So, I mean, you come from San Diego. You come from where you live is at sea level.
Mm-hmm.
So you're at zero sea level.
Any directions, 10 minutes, you get a beach.
Exactly. And then you come to Saline at 7,500 feet above sea level. That's 1.5 miles. So you go from sea level to 1.5 miles above sea level. The air's thinner up here. The first time I tried to run here, I couldn't believe it. I could barely go 100 yards without breathing hard. I couldn't run because the oxygen's so thin. But of course now I'm used to it. I've been here for 4 years, so I'm pretty much used to it. But when I first got here, it was a real struggle. I could feel it. I could see it in my eyes. Because I knew I wasn't getting enough oxygen. I'm just not used to it. So every time you go to a different environment, you've got to get used to that area. It's what used to happen in Mexico. People would go down to Mexico and they'd get diarrhea, they'd get dysentery, they'd pick it up. Well, why in the world don't all the Mexicans have the same stuff? It's because they eat different foods than people from the United States do. They eat a lot of peppers, and the peppers protect them. It changes their immune system. So we need all of these different things to be able to adapt. Once upon a time, there were very few diseases in the Americas, in North America and South America. And then Europeans came over here, and Europeans had all these diseases. So what happened to the human population of the Americas, the indigenous peoples of the Americas? Well, they got sick. Yeah, they got the measles, they got mumps, they got chickenpox, they got smallpox.
What was the Black Death?
Black Death was the bubonic plague. And we just had 2 cases of bubonic plague that this guy killed a rabbit and he ate it. He was a hunter. He killed a rabbit and he put it in his pocket, or he put it in his bag, and it had fleas, and the fleas had bubonic plague, and now he has bubonic plague. I've seen this before. When I was stationed in Lubbock, Texas, there was a bubonic plague outbreak in the Jicarilla reservation in northern New Mexico, and we had to go and try to figure it out. So all this immunity, you know, this is. Every place you go, you need to develop immunity. It's one of the reasons why every time they sent you someplace, they gave you shots for something. Yellow fever, probably.
Anthrax and smallpox.
Yeah, well, smallpox. The crazy thing about smallpox, we eradicated smallpox, and then it broke out again in Syria, in some of the refugee camps in Syria. We thought we had it eradicated. My daughter had a smallpox vaccination she was born in 69. She had a vaccination. My son was born in 72. He did not have a smallpox vaccination. I had a smallpox vaccination when I was 6 years old. I guess I was 5 years old. Then I had another one when I went to college. They gave me another one. Then when I joined the military, they gave me another smallpox vaccination. And
yeah, I still got my scar. That's how you can tell if someone's really bit the blood or not.
well, you can tell how old
Let
someone
me
is.
see your scar.
Exactly. Yeah, I got a scar right here on my shoulder.
And it's crazy because I couldn't touch my son because they said you have to wait till it turns black.
Yeah,
Don't pick at it.
Yeah.
Wait till it falls off by itself.
exactly.
And I finally did. So I got gloves, put it in a bag, and it was in Texas, so I just burned it in my backyard. No big deal. But yeah, I couldn't really hold my son. So
Until your smallpox vaccination went away.
yeah,
That's actually not smallpox, that was cowpox.
in country, we had to get a frigate and another anthrax
Uh-huh.
because these Tajis over there, they're smart about using it, you know. And oh man, and it wasn't just like a needle; it had like two. I was just standing there attention. I mean, obviously they switch them, but man, that needle hurt a lot,
I know, I've had those shots.
and it burns.
They do a better job now than they used to do.
Yeah.
Yeah, because they used to use actual needles. They had to give you an injection, and they had to stick it almost into your bone. I mean, it went all the way through your what is this muscle? Well, anyway, your deltoid. Had to go all the way through your deltoid to your bone in order to get it into the right place. And if they didn't stick it deep enough, it didn't take, then you'd have to get it again. This is in the old days. Anyway, so this has to do with immunity. So wherever you go, and one of the reasons we have to keep injecting military personnel with different inoculates is because they're going into areas where these are problems. Potentially they have problems. Luckily, the human body has different types of leukocytes, and each leukocyte will combat a different type of an infection. These cells right up here, these dark ones, are called basophils. These fight metal toxins, so any heavy metals that you may come in contact with, it will encapsulate those, and it won't allow it to poison you. That's the basophils, these right here. These orange ones are known as eosinophils, and eosin is just the stain that they use to stain them with. Eosinophils have to do with allergens, and
So what happens? You're allergic to something, right? Like me, I'm allergic to mushrooms.
if you're allergic to mushrooms,
So what happens with all that stuff? That eosinophil,
eosinophils.
it just doesn't work.
No, what will happen is if you get around mushrooms or you eat a mushroom, then there will be an increase in the number of eosinophils.
Okay.
Okay. If somebody has asthma, they'll have an increase in the number of eosinophils. And that will fight the allergens. That will fight what is causing their problem. If they didn't have an increase of eosinophils, they would die of asthma. So they need the eosinophils to fight the asthma. Eosinophils are also increased if somebody has parasites. Now this is a really serious problem that we've had wherever we've fought wars. Iraq had different parasites than we have in the United States. So did Afghanistan, but especially Vietnam. Vietnam had lots and lots of parasites. So the individuals, and this is one of the things that happened because I was working in the hospital. I was working in the hospital when the POWs came back. As a matter of fact, John McCain was in our hospital at Wright Pat. because his dad was, at the time, his dad was stationed in DC. Well, no, it wasn't in DC. His dad was someplace close. His dad was an admiral. Anyway, when he came back to Wright Pat. Then they sent him to Walter Reed. But when he first came in, we had to check all these people for parasites. He was loaded. All those guys were loaded with parasites. And the reason is because they gave him not very good food. It wasn't sterile food. Now, as far as the Vietnamese were concerned, it was okay because they're around these parasites all the time. It doesn't bother them. Mm-hmm. But because we were Americans and we eat the stuff that we eat, they weren't used to these other parasites. They couldn't fight off the parasites. So he was just loaded. He was loaded. Well, they were all loaded. We got 15, I think. We got 15 of the POWs when they came back. They went all over the country. They went to San Diego. They went to McConnell up near San Francisco. They went to down to Florida, Egland in Florida. They went all over the place. Whatever hospital was closest to their home. Usually it was where they were born. Of course, McCain was born in Panama, but his dad was stationed in Panama and he was born down there. But I think his dad was somewhere in Ohio. His dad was a Navy admiral. Anyway, all these guys came back with parasites. Real serious problem. So one of the things that I had to learn when I was in the military was to identify all these parasites, because we saw them all. Malaria was another one that we had to be able to identify.
What exactly is malaria?
What?
What is malaria?
Malaria is a...
I kind of know what it is. I know it's like like dysentery, all that other stuff, but like, because they gave us pills,
quinine.
Second tour, I think.
Yeah.
For that.
Yeah.
But I didn't take it. Because it gave me some fucked up dreams, so I stopped taking it.
Huh. I wonder what they're giving people now. Malaria is a bacteria. It's a bacteria that is spread by mosquitoes. So if a mosquito bites you, if it's an Anopheles mosquito, the Anopheles mosquito has all these, and there's like 5 or 6 different types of malaria.
I wonder why they gave it to us, because where we were in RC North by Mazir Sharif, and that's by the mountains. There'll be no mosquitoes in the mountains. It's too cold. Like you can see, what is the name of the mountain?
There has to be water. I mean, there has to be mosquitoes. Malaria is spread by mosquitoes. So equatorial Africa, where it's very humid and there's a lot of mosquitoes, any place that has a lot of mosquitoes, malaria is fairly prevalent. Remember the Zika virus? Okay. The Zika virus, they were afraid it was going to come to the United States. It was down in South America, and it walked its way up into Central America, and they were afraid it's going to make its way into this area. Well, it could have, except the desert kept it from spreading in the United States. They found it in Florida, they found it in around Houston, in Louisiana. It was in Louisiana, but it never came this far north. And the reason it didn't come this far north is because the mosquito that spread the Zika virus was the Aegyptus mosquito. And the Aegyptus mosquito can't live above 6,000 feet. So it was too high here. The mosquito couldn't survive in this low oxygen level. So we were safe here. We would have been safe in Salem. My niece was pregnant at the time, and she was in Indianapolis. And Indianapolis is like at 400, 500 feet. And of course, there's a lot of water around there. It's farmland. So potentially, she could have contracted the Zika virus, but it didn't go that far north. Didn't make it up into Indiana. But I suggested that she come here during her pregnancy so that she wouldn't contract the Zika virus, as weird as that is. This kind of stuff's going on all the time, and our bodies need to fight all this stuff off. as indigenous peoples in the Americas, of course, you didn't have any natural immunity to any of these things. Now, why in the world did the Europeans spread so many diseases? Well, the reason the Europeans spread diseases is because they lived with their livestock. They lived with their pigs. And pigs have a very similar immune system to humans. So all these diseases, measles, mumps, chickenpox, smallpox, all of these things were being grown inside the pigs. And because they live with their pigs, they still do live with their pigs, by the way. I know, this is weird. If you go to Germany and you go to a farm homestead, and their barns are underneath their houses. So their houses are up here and their barns are down below. So if they have, waste that they need to dump, that they need to get rid of, they just dump it down in with the pigs. So if I'm eating a salad and I've got a cold, and I don't finish my salad and I dump the rest of the salad into the pigs, now the pigs have the virus.
Most pigs are raised.
And then it
food,
mutates.
so
Exactly.
it just recycles back.
And then it mutates, exactly. And then we eat the pigs, or we get around the pigs, and we get the same diseases. The same thing happens with the flu every year. Asians, have you ever been to China or?
No.
Okay, or Japan or Korea?
Mm-hmm.
Okay. They use human waste as fertilizer. And then after they harvest whatever they're going to harvest, rice or wheat or whatever, once they harvest, they allow the pigs into their fields. Well, they have used human waste as fertilizer. So the pigs get to root around in the human waste. So every year the pigs come up with a new form of influenza. This is one of the reasons why we can't, why we don't know what the influenza is going to look like this year, because what we do know is what it looked like last year. But every year it's a new influenza coming in from Asia. And then it walks its way across the United States.
Asia's just.
It starts in California in October, and eventually it just walks its way all the way to the East Coast. It used to actually walk its way across. Now it kind of flies its way across. So we have two outbreak areas. We have an outbreak area in the Los Angeles, San Francisco area, San Diego area. That's where it starts. And then we have one in New York and Washington, D.C., especially Washington, D.C., where we have a lot of foreigners coming in. And of course, they bring the flu with them.
There's a lot of like Asian, like LA has Koreatown, Chinatown, and there's a small, like 4 blocks called Japantown. San Diego, there's Chinatown, Little Italy, and Koreatown.
Unless the people are coming from
And
Asia.
Little Manila.
Right.
A bunch of, it's like Filipino.
But unless people are coming from Asia, of course, they're not going to bring the flu. It's when people fly from Japan or Seoul or Shanghai or whatever. If they come over here, they usually land on the West Coast first, and then they go wherever they're going. But it usually starts on the West Coast. The flu does. Right now is the flu season. Right now is when it's.
It makes sense because LAX and freaking Limburg, not Limburg. Forgot the name of my freaking airport. San Diego.
In San Diego? I've flown into San Diego.
Yeah, I just.
But I can't remember the name of the airport.
But LAX is like the main freaking. It's international.
Sure. And then they go
San
where.
Diego's too. I think international too.
Well, Asians are kind of interesting. They don't, it's not like we're gonna go to Topeka, Kansas, it's not, there's not a whole lot of Asians in Topeka, Kansas. So they usually stay in more settled areas. Anyway, so we have all of these, our immune system has to do with all these white cells, and they're all different types of white cells. So one of my jobs, well, we've got basophils that fight off metal toxins, eosinophils are allergens and parasites, lymphocytes fight off viruses, neutrophils fight off bacteria, and monocytes fight cancers. Now, if we look if you look at this picture, you can see that they don't look the same. These are neutrophils right here, and we can identify them by their shape and by their color. These are monocytes, these ones in the right-hand corner. This is what they look like, they're larger cells. These are lymphocytes, these are smaller cells. They kind of look like monocytes, but they're smaller, and they have a circular cytoplasm. Nucleus, I'm sorry. And of course the basophils are dark, and the eosinophils are orange. And you can see this. So one of my jobs when I was in the military, and if I went to work in the lab, in a laboratory right now, one of my jobs would be to do what they refer to as a differential. In other words, I count 100 white cells. I count 100 white cells and I identify what type of white cells that they are. Normally, you will have about 50 to 60% of all the cells that you see will be these type right here. 20 to 30% will be these type, and then you very rarely see this type, or this type. You have to have asthma to have a lot of eosinophils or a parasitic infection. You have to have ingested some heavy metal in order to have basophils. And you have to, normally you don't see these very often at all, these monocytes, because they fight off cancers. So the vast majority of the cells that you're going to see in a blood smear will be neutrophils and lymphocytes. Neutrophils, of course, fight off bacteria, and the lymphocytes fight off viruses. However,
How does it look
I'm
for
sorry?
a person with diabetes?
Diabetes doesn't affect your immune system.
Does it?
Mm. Yeah, so you can't tell if somebody's diabetic just from looking at their blood smear. However, if somebody has a cut on their arm and it's infected, we'll see an increase in the number of neutrophils. If somebody has appendicitis, appendicitis is usually a bacterial infection. We'll see a huge influx of these cells right here, of the neutrophils. If somebody has mononucleosis, we'll see a vast increase in these guys. If a kid has lead...
What does it look like when someone has HIV?
HIV?
Mm-hmm.
HIV, one of the things that we will see is that they will have a lower white cell count.
Okay.
Okay. And not only that, but they will have fewer of these and fewer of these. If we have a kid with lead poisoning, we get an increase in the number of basophils. If some kid has lead poisoning.
Is there a difference in that view of like that thing where your blood doesn't clot?
Oh, if you have hemophilia?
Yeah.
Yeah, these are called platelets. These are platelets, and they cause your blood to clot. We'll see a decrease in the number of platelets. So we can tell if somebody has...
So you can tell a lot.
Yeah, you can tell a ton. If you're thinking about these things, I mean, when you look at a slide, blood looks like blood, you know? But you've got to count all these things, and you're trying to identify whether they're abnormal forms or whether they are immature forms. If you have lymphocytes and somebody's got mononucleosis, he's going to have a bunch of cells that look like this. But what they are immature lymphocytes, because lymphocytes look like this before they mature. These are lymphocytes that are ready to fight.
Can you tell the difference?
The difference, this is weird. Yeah, the difference is that the cytoplasm is a different color and different shape.
Okay.
But it's not that extreme. So a lot of times you misidentify a cell. It's really easy to misidentify something.
So this is what you did? You just looked at
It's what I did, yeah.
stuff under a microscope?
Yeah, And you needed to learn all this stuff.
Hey, did any of your guys get out and work for like CDC or anything?
Most of them got out and worked in hospitals. Our training was, we had the longest training of any, you call them MOSs, we call them AFSCs. We had the longest training of anybody in
Probably
the
like, what, like
service.
6 months, 8 months?
No, it was 18 months.
Well, I guess so, yeah.
I mean, you had to learn everything. We not only had to learn about the immune system and hematology, but we also needed to learn about chemistry, microbiology, parasitology.
That's
Yeah.
college all over
I
again.
know. It was tough. It was long and hard.
Yeah, mine wasn't that long. It doesn't take long to kill somebody.
You know, learn how to shoot a gun and clean the damn thing. Okay, and we had to learn how to identify all this stuff. We had to learn how to identify malaria. We had to learn how to identify parasites. We had to learn how to identify
But was it
hemophilia.
hard? Because by the time you're done with school and there's new shit coming out.
You're almost done, yeah. Well, so we spent 6 months in primary training, and then we spent 18 months in actual lab training. So that's 2 years. We only had 2 years left in our enlistment. But that's what you have to do in order to have people that can identify this stuff. You gotta train them for 18 months, and you have to train them in everything.
Psychology.
I'm sorry?
How'd you get into psychology if you're doing this? You got tired of looking at...
No, I love doing this kind of stuff. It's great. I mean, normally you just see everybody's normal. You know, everybody that comes in is normal, but every once in a while you'll see somebody that's sick.
There's something more.
Yeah, and you go, oh man, this is great.
Because you're mystery, that's what it is.
Well, you're trained to identify this stuff, and almost everybody that comes in is normal, but every once in a while you get somebody that's really sick. You know, somebody with an allergy, or some kid that comes in with lead poisoning, you know, and you just, it really makes your day, as weird as that sounds. Or you'll find somebody with leukemia, which is just a heartbreak, because back when I started in the lab, we couldn't cure leukemia. So if a kid came down with leukemia, it's like 70% of the time they died before they were, you know, within the year. So we were...
What is it?
I'm sorry?
What does it attack?
Leukemia is cancer of the blood. It's where the blood cells, they're not producing enough red cells, or their white cells are going crazy. They're just replicating, and so they would have all of these immature forms. And they would die because their immune system would break down, and so they just die. So we'd lose them.
Is it possible to, because I mean with HIV, it's kind of the same thing, isn't it?
I was in the lab when we first discovered HIV.
But I mean, the symptoms as far as looking at that, the same as leukemia, right?
No.
No?
No, it's different. Leukemia is usually an increase in the number of cells, and HIV is a decrease in the number of white cells.
Yeah, I had a family member who died of AIDS.
AIDS?
That
Yeah, it's tough. Yeah, I
he
was
just sharing needles.
I was there
That's probably
when.
the quickest way to freaking get it.
Well, of course, it's the dumbest way to do it. Yeah. I was there when the HIV thing first broke, and we had no idea what it was. We didn't know if it was a virus. We didn't know if it was a bacteria. We had no clue. We just had people dying. Mostly gay males were dying. Then it got into the drug culture. So we started losing females. In the beginning, when the gay males were dying, nobody cared.
No.
I mean, nobody cared, and so nobody did anything about it. So we've got all these people just, you know, dropping over dead, wasting away until they died in the beginning, and it wasn't. And this was in the early '80s, and we didn't start doing it. We didn't even identify it until '85. I know.
That's
That's a
a lot
problem.
of people freaking dying.
Well, that's a real.
Until, I mean, some be looked at or whatever.
We needed to do something. So in 1985, I had a ruptured spleen. My spleen ruptured. And so I needed 6 units of blood, and I got 6 units of blood, but we had no way of telling whether the blood was contaminated with HIV. Had no way of telling it. We couldn't identify it. So I got 6 units of blood, and potentially one of them, or all of them, could have been tainted with the HIV virus. But we didn't know because we couldn't even identify it at that point. You just had blood, and I was lucky. I guess I got 6 units. Either that or my immune system is strong enough that if there was HIV in there, it knocked it out. I know. Anyway, so we've got all this stuff going on. It's too much fun. The immune system is very adaptive, thank God. The question you have to ask yourself is, when the Europeans first came over here and they brought all these horrible bacterial infections, why in the world didn't all the American Indians die? The answer is about 99% of the American Indians probably did die. We had whole sections of the Americas where there were no people, but there had been people there before. All the people were wiped out. They all died of something, and it was probably the bacteria that was being spread by the Europeans. One of the reasons why the Incas and the Aztecs were so easy to conquer was because these were military groups that had taken over entire sections of the world. And so why in the world could 500 or 600 Spaniards suddenly be able to defeat Montezuma in Mexico City, or what's his name? What was his name? Wait a minute. The Inca, the guy that was in charge of the Inca. How in the world were they ever able to do that? These were military men. These were vicious, brutal people. These were individuals that had taken over all the tribes in the area. How in the world were the Spanish, this small group of men, how were they able to do that? And the answer was because all those Indians were sick. That's why they were able to do it.
Yeah.
The smallpox.
They just gave up.
Well, they didn't give up. They died. They were dying. There was no giving up to it. They just croaked.
For the extinct.
And American Indians could have gone extinct.
Actually, there is a tribe. You heard of Ishi, right? Yahi.
Oh, they're Yahis?
Yeah. No, it doesn't exist anymore.
Oh, okay.
Like, I mean, he's in history books. Ishi.
Oh, yeah, that's the guy. He was in California. I know who you're talking. He was the last member of his
I
tribe.
think it was about the same thing.
Yeah, and
they killed them all, or they got sick.
and they got sick and died, of course. But at that time in California, of course, it was open season on American Indians.
Free the gold.
Yeah, yeah, they were trying. It was genocide, is what it was, and they were killing off as many as they could find. Any of them that they could find, they referred to them as diggers, I know who you're talking about. And he went to Berkeley or someplace, and they kept him alive. He died in his 30s. But they thought he died of a broken heart, which is a possibility, I guess. Yeah, I know what you're talking about. But he would build, and he showed them a lot of different things about how they built their home structures and whatnot. Anyway, so we are adaptive, and of course, in order for somebody to survive, somebody had to adapt.
Oh, he died of TB.
Yeah. Isn't that sad?
1916.
Yeah. Last of his tribe.
So he was. When was the big quake in Frisco? That was like 30 something, wasn't it?
Yeah, he was in his 30s when he died.
He was 50. Dang, that's
sad. The immune system is very adaptive and maintains itself through several structures. The more you're around something that can potentially be infective, the more likely that you will adapt to that thing. In other words, I am here now, I'm in the mountains of Arizona, I'm at 7,500 feet. I have adapted to whatever diseases are in this area, despite the fact I don't have a spleen, I'm spleenless. The B lymphocytes comprise the humoral immune system. These are cells that are produced in the long bones. If somebody has leukemia, a lot of times the cell producing areas, the red cell producing areas, and the white cell producing areas in your long bones will go crazy, and they'll start either producing too many, they'll stop producing red cells, or they will produce too many white cells. The B cells produce antibodies or immunoglobulins that either directly neutralize the antigens of the foreign body or enhance the destruction of other cells. So when a foreign body comes into our system, a cold virus or a bacteria, the B cells will identify it. They will attach antibodies to it, and that will call a cell that comes and engulfs it and destroys it. That's the way it works. So when you catch a cold, if you catch a cold, one of the things that will happen is that you will have a lot of white cells going to that area trying to encapsulate all the viruses.
I have a question.
Sure.
When I was born, I had pneumonia.
Okay.
How does that happen?
Okay. How did that happen?
I was in incubator for I think 3 weeks.
Okay.
Because you're coming straight from your mother,
Sure.
and I mean you're not really exposed.
You don't have any immunity at all. The most dangerous.
Was she sick or?
No. It was probably in the hospital.
Hmm.
And this is one of the reasons why hospitals are so sterile. Because there are a lot of individuals who have either no immune system at all, or have a very small immune system, or they have a depleted immune system. They're immunocompromised. When you're sick, you're immunocompromised. In other words, your immune system isn't working properly, otherwise you wouldn't be sick. So all the individuals that have the flu, or they have pneumonia in the hospital, they're all immunocompromised.
So I caught it.
You were immunocompromised, and so the pneumonia was there in some form. Now, the interesting thing about pneumonia is that it can be caused by just about anything. It can be caused by a rhinovirus, which causes colds. It can be caused by bacteria that cause pneumonia. It can be caused by the bacteria that causes pink eye. It can be caused by just about anything. The flu virus. I'm sorry?
What is pink eye?
Pink eye is...
I know your eyes like reddish, but I mean...
Pink eye is caused by a bacteria that infects the mucous membrane covering your eye. It infects the conjunctiva. And that's why they call it conjunctivitis.
And
It's a specific bacteria.
Right?
I'm sorry?
Is it contagious?
Yeah, oh, very contagious,
Really?
extremely contagious, yeah. Yeah,
I was
so,
wondering because a buddy of mine had that, and he's man, I gotta wear this patch till it's done. I don't know why. He goes, one of those gets it. He goes, this bears to cover it.
oh, yeah. I
So,
mean, if
you
you,
look like a pirate, bro, you know.
if you touch the guy, this bacteria spreads all over the place. If you touch the,
He always wears combat gloves.
yeah.
Doesn't matter if we were in a brief or mission brief, whatever. He always was covered.
I'm surprised they even let him in the room. Did anybody else come down with conjunctivitis? It's highly contagious.
Like where I was sitting, it's like where he would sit and everybody else would be sitting over there.
Yeah. Yeah, if you touch anything that he touches, then potentially you'll get it. All you need to do is get it close to your eye. This is not a bacteria that you get it on your finger, then you put it in your mouth. It'll kill it because it is specific to the eye, the conjunctiva of the eye. So if he touched the table and you touched the table and then you scratched your eye, now you've got
If you
conjunctivitis.
touch table and like scratch your.
Scratch your hand, nothing, yeah, because
So it has to be eye to eye.
eye-to-eye contact, yeah.
Dang.
There's a lot of bacteria that are very fastidious. They're very specific to specific areas. The warts are caused by cytomegalovirus. It's a virus. Cytomegalovirus. And if you've got warts, if you've got genital warts, you can't like scratch your crotch and then scratch your face. Now you got warts on your face. Doesn't work that way. That cytomegalovirus, even though all the warts that you have on your body is exactly the same type of virus, if it's on your hands, you can't give it to your feet.
It's gotta be.
It's
the same
specific
part.
to that area, as weird as that sounds. So if you've got a wart on your foot and you scratch your foot and then scratch your face, you're not gonna get warts on your face. It doesn't work that way. If you've got warts on your hands, you're not gonna get warts on your feet. It just doesn't work that way. It's one of the I've run into a lot of people with genital warts, and they didn't have warts anywhere except on their genitals. And I can assure you that they were scratching those suckers, because they itch like crazy. So they were scratching themselves, and then weren't spreading it anyplace else. So there's a lot of bacteria that's very specific like that. Herpes virus. If you've got genital herpes, it's not like you're going to scratch yourself and then you're going to get herpes in your mouth. It doesn't work that way.
Canker sores are a form of herpes, right?
Yeah, that's oral herpes.
So is it, well, that's not really contagious.
But you can't get, if you've got oral herpes, you're not going to spread it to your genitals. It doesn't work that way. This herpes is only here, this herpes is only here.
That's weird, because I mean, it's all the same body, you got the same stuff floating around.
Well, it's a different, they're all fastidious. They all just infect specific areas. Okay, so we're trying to build up our immune system, and we've got all these lymphocytes that are coming out of your bones. And these are the lymphocytes that will attach antibodies to the infective substance, and then another cell will come along and it will kill it. Those are the B cells. But B cells aren't the only type of lymphocytes that we have. Cell-mediated immunity involves lymphocytes formed or converted in the thymus behind the heart. So you have this chunk of meat right behind your heart. It's called the thymus. It's an organ, and it produces lymphocytes right behind your heart, your thymus. And these are called T cells because of the thymus. There's 3 different types of T cells. T helper cells that produce interleukin and lymphokines, and it's the T helper cells that are infected by the HIV virus. It took us forever to figure this out. Nobody thought of looking at the white cells to find the infection. Most infections don't invade your white cells. The T helper cells are the ones that identify the bacteria or the virus as an alien form. That's their job. They're the ones that run around your body tagging these things with immunoglobulins. But there are 2 other types of T cells. There are T killer cells, and these things run around your body killing bacteria, killing viruses, the T killer cells. So you need as many T killer cells as you can possibly get. This is a good thing. These guys run around the body and kill things.
What's the average number a person has? Does it vary?
It varies on how strong your immune system is. The more stress you're under, the fewer of these guys that you have. And this is one of the reasons why when people are under a great deal of stress, they catch a cold or something else. They get sick when they're under a lot of stress. Then we have, but if we had just a ton of these guys running around our system, pretty soon they would start attacking our own system. And this is a autoimmune disease. This is what
So they need something to feed on.
they attack.
Okay.
And if they attack anything that's alien, anything that's foreign, anything that they identify as foreign, this can be a problem, because if your immune system is too strong, then you'll start attacking your own body. And we see that in autoimmune diseases. Rheumatoid arthritis is a form of autoimmune disease. Lupus is an autoimmune disease, where they have started attacking the connective tissue in their bodies.
Cancer too?
I'm sorry?
Is cancer linked?
Cancer is an adaptive disease. It's not really autoimmune. Well, it kind of is, isn't it? Yeah. T suppressor cells suppress the humoral reactions. We need the T suppressor cells so we don't get autoimmune diseases. Psoriasis is an autoimmune disease. That's that skin disease, where you get scabby skin.
Oh, yeah, yeah.
Yeah, dry spots on your skin. Yeah, it's an autoimmune disease. Besides B and T cells, a major leukocyte in circulation is a cell that does not require an antigen to trigger the immune cell. This is a natural killer cell, or the NK cell. It is a free-floating granular lymphocyte that recognizes stressed or alien cells and destroys them without the antigen-antibody connection. In other words, we've got all these old cells in our body that need to be replaced. So how in the world do we identify them? Well, this is the guy that identifies them. It identifies all the old cells in your body and replaces them. If we didn't have NK cells in our body, we wouldn't live past 2 or 3 years old, because we need to replace all the old broken down parts. Now this will happen, and of course, when we talk about aging, how people age, some people, they die of old age in their 60s and 70s. Other people live into their hundreds. Now how in the world does that happen? How do we have this? How do some people genetically, how can they live into their hundreds, and other individuals, they can't make it past their 60s or 70s? What's going on? Well, what's going on is some people have an immune system that works for an extended length of time, and other individuals don't. Now, there's a problem. And the problem is that if you use something that accelerates your metabolism, like crystal meth, or heroin, or if you do something to your body, if you do something negative to your body, like become an alcoholic, exactly, where a lot of cells need to be replaced because you're drinking a toxin, you're consuming a toxin, and that toxin is bothering your liver, it's destroying your liver, and you have to replace all of those cells in your liver. Now all of a sudden, your immune system only can work so long. If you're a good boy and you don't do any of these stupid things for all of your life, potentially you'll live into your 90s or 100s. But if you're a bad boy and you take crystal meth, you smoke crack, or you drink a lot of alcohol and you mess up your liver, now all of a sudden you're only going to live into your 60s or 70s. This is the way it works. You can't stop and then everything's going to go back to the way it would have been. It just doesn't work that way. If you mess up for an extended length of time, you're just shortening your life. Most people, when they drink, they don't care that they're shortening their life. When they take crystal meth, they don't care that they're shortening their life. You can't convince them of that. So you get what I refer to as life debt. Life debt has to do with years. You've got a certain number of years that you can possibly live. And of course, your life can be terminated at any point with an accident or with,
combat, I mean, all kinds of crazy stuff could happen to you.
If you have like a piece of metal in, no, it's not. Never mind.
I was playing in a soccer game, 1985. I scored 2 goals. I was about to score my 3rd goal. Goalie got pissed and he rugby tackled me. And when he rugby tackled me, he hit me in the chest. He hit me right here in the rib cage. He ruptured my spleen, so they had to take my spleen out. Your spleen is one of those areas one of those things that you need.
What's an appendix for?
Nothing.
I hope we don't need it.
It's vestigial. It's what we refer to as vestigial.
But
Once upon a time, when we were a lower form of animal, we needed that chunk of intestine. But now it's just a vestigial
But I
form.
heard if it busts, it's toxic in there.
Yeah, well, yeah. If it burst, it's because it became infected, and the bacteria that was in there that caused the infection will now get into your abdomen, and it causes.
All that stuff is.
And you can potentially die because it's bacteria, and it causes this mass infection in your gut.
Is it like bile or what is it?
It's bacteria, it's pus, it's inflamed, it's poison. It's not very good stuff. So if you don't get your appendix taken out when it's inflamed, then you'll get an infection in your abdomen and you'll die.
But a lot of people don't even need to have it taken out, right?
Well, not if it never gets infected.
Okay.
And the question is, why the hell did it ever get infected to begin with?
How does it get infected?
Well, bacteria gets down in there and it accumulates, and all of a sudden it just festers and,
Oh, so it's gotta take time.
yeah,
Okay.
yeah. And I still have my appendix. Do you still have your appendix? Okay. Sure.
I've only had like one major surgery. I was on my knee.
Oh, just on your knee, okay. So I've had more surgeries than you have, okay. What are we doing? What are we talking about? Oh, we're talking about natural killer cells. This cell is produced besides the thymus or the bone marrow, the spleen and the tonsils. So you have all these NK cells that are wandering all over your body. And they're being produced in your tonsils, if you still have your tonsils, your spleen, your bone marrow, and in your thymus, these natural killer cells. Your immune system is an amazing structure. If it becomes too strong, it will start killing your own body.
Dang.
I know, so you got to keep everything in balance. How do you throw
The yin and yang thing. Huh?
the whole yin and yang thing? Exactly, Hojo, exactly. So how do you control this thing? Well, you control it by controlling your stress, by eating healthy, by exercising. All of these things can help your immune system.
Can certain medicines like screw this up?
Yeah, that's a problem.